So, hello class, this is Jason Chaudhary. So today we are going to learn the very interesting topic, that is graph data structure. So we will learn the agenda for the lecture is we will learn what is graph, how to implement the things in the graph, how to implement it using the adjacency list, and if time will permit, I will show you also why the adjacency matrix, and I will show you the basic CRUD operations on the graph, like how you create a graph, how you can delete the node, how you can add the vertex, how you can remove the vertex, each and every steps, and how you can implement it using the class in the JavaScript. So now let's begin. So the first and foremost thing that I want you to know is what is a adjacency list or matrix, and how you are going to create it or how you will do it. Okay, so let's proceed, friends. So what is that the next that we have now? So let us create a graph. Let us create a graph. Okay, so let us assume that we have a graph something like this. Like this is the one which is connected to 2, and 2 is connected to 3, and something like this. I'm sorry, 1 is connected to 3, 2 is connected to 4, and 4 is connected to 5, and 5, something like this. Now let us try to connect these things. So now let us make all of this a node. Okay, so this is one node, this one is another node, this one is node, and this one is also a node. Okay, and this one is also a node. And don't worry about note downing the each and every step. Don't note down. I will provide you this whole PDF. So just keep your focus on learning. Okay, so we have these nodes, right? So now let us connect these things. Okay, so this is an undirected graph. This is connected with this thing, this is connected with this thing, and let this is connected with this, and let this 4 is connected with this one. Okay, and let us say that this 5 is connected back to the 2. Okay, so let us assume this is our graph. Okay, or you may want, like, you can also connect these two things. Okay, so let us say this is our graph. Okay, so what is adjacency matrix for this thing? So this is a graph, as we know. So what would be an adjacency matrix for this thing? Okay, so as the name suggests, adjacency matrix means adjacency. Okay, adjacency matrix. So adjacency matrix means 2D representation, 2D representation of how the nodes are connected, right? Good. So what is adjacency matrix? Now can you answer? Good. I hope you find it. Okay, so adjacency matrix is like it is just the 2D representation of how the nodes are connected. So let us build the adjacency matrix for this example. So this is example 1. Okay, and now let us try to build the adjacency matrix. You say, so adjacency, okay, adjacency matrix for given graph. Okay, so let us try to understand what would be the adjacency matrix for this. Okay, so the adjacency matrix for this graph is, so first we need to write down, like, what are the different how much edges, how much vertex are there. So count the total vertex. So count total vertex. Okay, so that is 5 in this case. Okay, so we have 5 vertex, so 5 nodes in this case. Okay, so we have to use a 5 cross 5 matrix. So many people used to do, many people says, like, if there are 5 nodes, you have to draw a 5 plus 1. Okay, 5 plus 1, that is 6 into 6 matrix, and many people says like you can do it using 5 into 5 matrix also. It totally depends on your choice, like what you want to do. I will tell you the both things. So let the people who says that for for having the adjacency matrix of a graph, you need, if it has n nodes, you need n plus 1 cross n plus 1 2D matrix. So they are also right. So what they used to do, they used to store it in the first place, like 1, then they store 2, they store 3, they store 4, they store 5, they store 6. Okay. And here what they store, they again store like 1, then again they store 2, then 3, then 4, then 5, similar things, right? So these things. So, and what they used to do here, is they used to fill like if between these things, if there exists anything or not. So they used to fill in this way. So this is 0. Okay. So they used to fill like if there exists any self loop, like one is connected to one or not. So if there is something like that, so we will fill 1. So 1 is connected with 2. So they fill here like 1 is connected with the 2. So we will go to the 1 and from here 2, and we will make here 1. Okay. Per here again 1 is connected to 3. So we will go to the 1 and we will put here 1 again. So in this way, you can see we are consuming one more extra row and one more extra column. So if we have the n nodes, so we are going to build n plus 1 into n plus 1 size of 2D array, right? This should be the size. Okay, this should be the size of matrix. And what matrix it is? This is called adjacency matrix, right? So this is people who agree with this thing. But what is preferable to do according to me is don't go for this one. Just go and create for 5 cross 5. So what we will do, we will not put the numbers here. We will just start assuming that this is 0 cross 0, this is 1 cross 1. Okay. So we will initialize something with this. We will take like there are 5 vertex. So we will build a 5 cross 5 matrix. So this is a 5 cross 5 matrix, right? So let us build it quickly. Okay. So I hope you might be getting these things, right? So we have these things. So 5 and 5. So we have 5 cross 5 matrix. So this is our adjacency matrix initially. We have initialized an adjacency matrix. So what we have done? We have done just var adj matrix is equal to this thing. Okay. And this is typically what? This is typically our 2D array, right? This is typically a 2D array. Okay. I'm not going to put all those comma stuff. It will take a lot of time, so you can understand it, right? So this is a 2D array, simple 2D array. Okay. Where we have all these things. So what we will do? We will just go and see that like 1 is connected to 1, 2 is connected to 1, like whatever is connected with which node, we will make it 1. So now let us go and do it. So first thing, try to see here, go for 1 comma 1, 1, okay, and see like with how many nodes it is connected. So assume that it is 1, 2, 3, 4, 5, and it is again 1, 2, 3, 4, and 5. Okay. So what you will do, see if 1 is connected to 2. Yes, 1 is connected with 2, right? So 1 is connected with 2. So what we will do? Okay. So we will go here. So, okay. And it is here we are starting the indexing with based on 1. Okay. So 1 is connected to 2. Okay. So this is the 1. This is okay. So from here, just try to assume it. Okay. So this is the 1. Okay. And now, so now what we will do is like, like from here, like we have we are 1 is connected to 2 and 2 is connected to 1. So just now start filling these things. So what we will be doing? So we will be doing 1 minute. Yes. So what we will be doing. So now let us just go and start writing here. So 1 is connected to 2. So just 1 is connected to 2, right? So go further, 1th row and second column. So 1 is connected to 2, make it 1. And since it is undirected graph, so 1 is connected to 2 and 2 is connected to 1 also. So make 2 comma. So this also, okay. So this is 2, this is 1, okay. This is 2 and this is 3, right? And this is similarly 4 and this one is 5. So what we have seen, like we have seen like 1 is connected to 2, so we have gone 1 and 2, and 2 is connected to 1, so we have did this thing also green. Okay, now again go and check. 2 is connected to 4 and similarly 4 is connected to 2, so 2 is connected to 4. Okay, so this is 2, this is 2 and go to 4. Okay, so 1 2 3 4, 2 is connected to 4. Okay, so this is 2 4 and go for 4 comma 2 also. 4 comma 2, so fourth row and so go to 1 2 3 4 and second. Okay, so here, so we have 2 comma 4 and 4 comma 2 also, right? Now again go for the fifth one, this one. So we are done with sorry, we are done with 2 comma 4. Now again 2 is connected with the 5, 2 is connected with the 5 also. Okay, 2 is, we have seen this thing, so this branch is done. We have seen this thing, so this branch is done. Now go and do something for this thing. So 2 will be connected to 5 and 5 will be connected to 2. So 2 comma 5 and 5 will be connected to 2, 5 will be connected to 2. So this is our 5 1 2 3 4 5 5 2. Okay, so this is 2 and this is 5, so 2 comma 5 also connected. Similarly go to 3, so this is also done, right? So now 1 comma 3 and 3 comma 1. Okay, 1 comma 3 and 3 comma 1. So 1 comma 3, right, and 3 comma 1. Okay, now again 3 to 5, go for this branch also, 3 to 5. So 3 to 5. Okay, so 3 comma 5, so 1 2 3. Okay, and similarly 1 2 3 4 5. So this one 3 comma 5. Similarly we have to go for 5 comma 3. Okay, so 3 comma 5 and similarly we have to go 5 comma 3. Okay, so 1 2 3 and 5, this one. Okay, so this is third. Yes, and this is 5 3 5. Okay, so 3 and 5 and this one was 5 and 3, right? Okay, so again, so this one is done. Now this thing left, 4 comma 5 and 5 comma 4. So go for 4 and then 5, 1 2 3 4 5, 4 comma 5. Similarly go to 1 2 3 4 and then 5 in this one. So this becomes your adjacency matrix. Okay, so all you need to do is you need to so if in fair I would like to say, so this would be look something like this, and then we can say like 0 instead 0 it is going to be 1. Okay, and it is going to be 0, it is going to be 0, it is going to be 1, it is going to be 1, then it is going to be again 1, it is going to be 0, it is going to be 0 0 and 1. Okay, and now again we need to write 0 then 1 then 0 then 0 then 1, then again it is 0. Okay, then it is 1 0 then 1 then 1 then 1 and then we have 0. So this is the adjacency matrix for this one that we have drawn. Okay, so this is what we know right now. Okay, so these are the things that we are done with. So this is adjacency matrix. Okay, so now